WASSCE 2018 May-June Physics Paper 2. So we are going to find solutions to some of the questions in this paper in this short video. So for the first question here, question 1 from the 2018 May-June Physics paper, we are supposed to define strain. So that's the A part. Then the B part say a rubber band is stretched to twice its original length. Calculate the strain on the rubber band. So let's start with the first one. Strain. Strain is the relative distortion or change in shape or size of an object. So the relative distortion or change in the shape of an object. That is what we refer to as strain. Now, for the B part, we have the object to be a rubber band. So the distortion is how it has been stretched twice its original length. Now we need to calculate the strain on the rubber band. So the strain, which is the relative distortion or change, the strain, which is the relative distortion or change in the shape or size of the rubber band, will be equal to the change in the length of the object. The change in the length of the object, which is the rubber band, change in the length of the object of the rubber band, which is the rubber band, over the original length of the rubber band. Original length of the rubber band or original length of the object. Now, let's assume that the original length is L0. Then the stretch will be 2L0, or the distortion will be 2L0. So the change will be 2L0 minus L0 divided by L0. So that is the relative change. And that will be equal to L0 over L0, which is equal to 1. Therefore, the strain on the rubber is 1. Our next question is name 3 classes of magnetic materials. Magnetic materials. Classes of magnetic materials. So we know that magnetic materials can be classified into different categories based on their magnetic parameters. So let's see let's see some of them, of these classes of magnetic materials. We have some magnetic materials that are diamagnetic. So for these materials, it creates an induced magnetic field in a direction that is opposite to an externally applied magnetic field. So these are the materials that are called diamagnetic materials. Then we have the paramagnetic materials. So in general, these materials also experience a feeble attractive force when they are brought near the pole of a bar magnet. Then we have the ferromagnetic materials. So in general, these materials, which are ferromagnetic materials, also experience a very strong attractive force when they are brought near the pole of a bar magnet. We have another question here, which is question 5 of the Physics 2018 May-June paper 2. A missile is projected so as to attain its maximum range. Calculate the maximum height attained if the initial velocity of projection is 200 meters per second and we are given gravity due to acceleration as 10 meters per second squared. So we recall that for the missile to attain maximum range, then the angle of projection must be 45 degrees. For maximum range, angle of projection is equal to 45 degrees. So we are going to use the relation or the formula h is equal to u squared, where u is the initial velocity, sine square theta, where theta is the angle of projection, all over 2 times of gravity due to acceleration. But from the question, we saw that the initial velocity, which is u, is equal to 200 meters per second. Then also, from the question, we can infer that the angle must be 45 degrees since it must attain maximum range. Then also the gravity due to acceleration is given as 10 meters per second squared. So with this information, we just have to do the substitution to get the maximum height to be equal to h is equal to, so the maximum height h is equal to 200 squared sine 45 squared. Note that sine square theta is the same as sine theta all squared. So let's do that substitution. So sine square 45 degrees is the same as sine 45 degrees all squared. Never forget that. Then all over 2 times gravity due to acceleration, which is 10. Now let's simplify. We evaluate 200 squared with our calculator. So 200 squared will give us 200 squared. 200 squared will evaluate to 40,000. 40,000. Then we know the expression for sine 45, which is 1 over root 2 or root 2 over 2. I'm going to use 1 over root 2. So all squared. So the whole of sine 45 is 1 over root 2 all squared. Now the 2 times 10 is 20. So let's simplify. We know 20 can go into 42 times. So that will give us 2,000 times 1 squared is 1, root 2 squared is 2. So this will simplify to 2,000 times half, which will be equal to 1,000 meters. Therefore, the maximum range is 1,000 meters. The maximum height is 1,000 meters. We have this question, which is question number 6. A black body radiates maximum energy when its surface temperature T and the corresponding wavelength lambda max are related by the equation lambda max times temperature is equal to constant. Given the values of the constant and surface temperature as 2.5 2.9 times 10 exponent negative 3 meters Kelvin and 57 degrees Celsius respectively. Calculate the frequency of the energy radiated. So from the question, we're given the relationship. From the question, we're given the relationship lambda max, which is the wavelength at maximum times the temperature, which was given in degrees Celsius, is equal to constant, which is also given in the question as 2.9 times 10 exponent negative 3 meters Kelvin. So from the question, we have the necessary information that can help us solve for the maximum wavelength. So the maximum wavelength, which is lambda max, can be calculated when we substitute the constant and the temperature. So let's make lambda max the subject. So lambda max will be equal to the constant, will be equal to constant over temperature. But we need to do some conversion for the temperature as well, so that we have uniform units. So this implies that our lambda at maximum, or the maximum wavelength, will be equal to 2.9 times 10 exponent negative 3 meters Kelvin, which is the constant. So 2.9 times 10 exponent negative 3 meters Kelvin over 57 degrees, but we need to convert the 57 into the 57 degrees Celsius into Kelvin by adding 273.15 Kelvin. So we simplify when we simplify all this, we use calculator in the simplification, and that will give us 8.8 times 10 exponent negative 6. So all this together, you add and divide the numerator with it. So this thing will be in meters because the Kelvins will cancel out. So this is our maximum wavelength. This is our maximum wavelength in meters. Also recall that there's a relationship between velocity, frequency, and lambda. So velocity is equal to frequency times lambda, where the velocity here, which is the speed, is the speed of light. And we know that the speed of light is having a value of speed of light is equal to 3.0 times 10 exponent 8. 3.0 times 10 exponent 8. So that is the speed of light. Then from this relation we can make F the subject, which is the frequency that is radiated, frequency of the energy radiated, as F equal V over lambda, where lambda is what we calculated for, 8.8 times 10 exponent negative 6. So we do our substitution to get the speed of light, which is 3.0 times 10 exponent 8 all over 8.8 times 10 exponent negative 6. So the 6 is negative, but the 8 is not negative. 8 is not negative. It's not negative. So you can now simplify this. You can now simplify this to obtain a standard form as 3.4. This simplifies to 3.4 times 10 exponent 13. So that is the frequency of the energy radiated. Is this? All right. So we are still on the physics 2018 WASSCE May June paper 2. So let's turn to question 8 now. The question 8 has various parts. So the first part is this: define uniform acceleration. So that is question 8a. Define uniform acceleration. So one thing that we need to take note of is how to supply or provide keywords in definitions. So when we are asked to give definitions, it's very important that certain keywords are provided. So for uniform acceleration, we can define it as uniform acceleration is the constant time rate of increase in velocity. Constant time rate of increase in velocity. So if you fail to provide the correct definition or include the keywords, so in this case we have keywords like increase in velocity, then we also have constant time rate. So if you fail to provide this, you will be penalized. So that is one thing we need to take note when we are asked to define. Okay, then let us proceed to the B part of the question 8. So this is the B part, and the B part is also having sub questions I. So question 8b: forces act on a car in motion. So car in motion is a moving car. List the I horizontal forces and their directions. I the vertical forces and their directions. So just imagine that a car is moving. So as the car is moving, there are certain forces that will be acting on it. So we have horizontal forces like the thrust, which is the force that will move the car forward. So the force that is moving the car forward is thrust. So the force now, the horizontal force now is thrust, and the direction is forward. So forward motion, direction is forward. But as the car is moving, there's another force which is also acting horizontally. But this time, it doesn't move in the direction of the car, but rather in the opposite direction. So it is opposing the motion of the car. And you know that force already? Yeah, the frictional force. So the frictional force moves the car backward. Frictional force to move the car backward. So another horizontal force is friction. Force of friction, and the direction is backward. Then now let's talk about the vertical forces. that will also be acting on the car that is in motion. So for vertical forces, we can talk about the weight of the car. Weight of the car. So you know weight is a downward force as a result of gravity acting on the body. So the weight of the car, which is acting downward, is also another force that acts on the car in motion. So the direction is clear, downward force. So the vertical force is weight of the car and the direction is downward. Then let's also think of another force that can act on this car. Yes. Apart from the weight, which is a vertical downward force, we also have a vertical upward force, which is called the normal reaction. The normal reaction. So the normal reaction acts upward. So these are the forces that will act on a car in motion, both in horizontal direction or vertical direction.